This is Notes 5-6, graphing using a point and a slope. Draw a line through the given point with the given slope. Number 1, graph the line y minus 3 equals 2x plus 6. This line is in point-slope form. Y minus y1 equals m times x minus x1. Our slope is 2. If I'm thinking rise over run, this is 2 over 1 or up to right 1. My points are 3 and negative 6 because it's the opposite sign of whatever's in my equation. However, I can also solve this equation to get it into y equals mx plus b. I'm going to start by distributing my slope. 2 times x is 2x. 2 plus 6 is 12. I'm isolating my y, so I add 3 to both sides, lining it up with its like terms. My new equation is the line y equals 2x plus 15. My b value here is 15, because this is y equals mx plus b. So my y-intercept, the x value for a y-intercept is always 0. To graph this line, the point 15 is way off my y-axis. So I've got to use this point we determined from our original equation. Remember, in the formula, since it's minus y1 and minus x1, our point is going to be the opposite signs of what we have here. The x value is the opposite sign of plus 6, so negative 6. The y value, the opposite sign of minus 3, so positive 3. I'm going to start at this point, negative 6, 1, 2, 3, 4, 5, 6, positive 3, 1, 2, 3. My slope was up 2 over 1, up 2 over 1. And I'm going to go back the other direction. And I draw a line to connect my points. I'm also asked for the x-intercept. Since my line does not cross as an exact point, I need to use what I know about x-intercepts. I know that for x-intercepts, my y value is always 0. So I can plug this into my equation. I can use either my original equation or the one we solved for. I'm going to use the one that we solved for. I'm going to say that y is 0 equals 2x plus 15. And I'm solving for x, minus 15 on both sides. Negative 15 is equal to 2x. And I divide by 2 on both sides. Negative 15 divided by 2 is negative 7.5. So the x value of my x-intercept is negative 7.5. Number 2, graph the line y plus 5 equals 2, parentheses, x minus 4. This is in the form y minus y1 equals m times x minus x1, point-slope form. My slope is 2. So if I'm thinking rise over run, this is positive 2 over 1 or up to right 1. From this equation, I can get a point that lies on my line. Notice in the formula, since it's minus y1 and minus x1, that means I'm going to have the opposite sign of these numbers. So the x value is x minus 4, so opposite of minus 4 is positive 4. Y plus 5, the opposite of plus 5 is negative 5. From this, I can go ahead and graph my line. I have the point positive 4, 1, 2, 3, 4, negative 5, 1, 2, 3, 4, 5. And I know that my slope is up 2 over 1. I draw a line to connect my points. I cannot see my y-intercept, so I'm going to have to solve my equation to get it into y equals mx plus b in order to be able to determine this. To solve, I'll start with distributing my slope to everything inside the parentheses. 2 times x is 2x. 2 times negative 4 is negative 8. I'm trying to isolate the y, so I subtract 5 on both sides, lining it up with its like terms. And I get y is equal to 2x. Negative 8 minus 5 is negative 13. This is in the form y equals mx plus b, so my b value is negative 13. The y-intercept, the x value is always 0, so my y-intercept is the point 0, negative 13. On my graph, my line does not cross the x-axis at a direct point, so I'm going to solve for my x-intercept using what I know about x-intercepts, and that is that the y value is always 0. So if I plug in a y value of 0, 0 equals 2x minus 13. I add 13 to both sides. 13 equals 2x, divide by 2. Thirteen divided by 2 is 6.5. So my x-intercept is the point 6.50. Does the point 9, negative 3 lie on this graph? I'm going to graph this point 9, negative 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 3. 1, 2, 3. This point is not on my line, so my answer is no. In summary, my steps are to plot the point. So I find the point from the equation, and plot. I use the slope to find more points. Find any key features we're asked for, like the y-intercept, x-intercept. And then use the slope and y-intercept to write the equation in slope-intercept form. Moving on to the back page. This is a review graphing y equals mx plus b in standard form. Number 3, graph the line 5x plus 4y equals 20. This is in the form ax plus by equals c. So this is standard form. In standard form, I'd like to find my x and y intercepts. For an x-intercept, remember that the y value equals 0, so I can cancel out the part of the equation that has y, leaving me with 5x equals 20. If I solve for x, I divide by 5 on both sides and get x equals 4. So my x-intercept is the point 4, 0. I find the point 4, 0 on the x-axis. Next, I need to find the y-intercept. For y-intercepts, remember this means that the x value is equal to 0, so I can cross off the part of the equation that has x, leaving me with just 4y equals 20. To solve this for y, I divide by 4 on both sides, and I get y equals 5. So my y-intercept is the point 0, 5. Since I have 2 points, I can graph my line. My b value, or my y-intercept, was 5. I can find the slope by counting rise over run on my graph. I'm going down 1, 2, 3, 4, 5, so negative 5 over 1, 2, 3, 4. In slope-intercept form, y equals mx plus b. My equation is y equals negative 5 over 4x plus 5. Number 4. Graph the line y equals 2x minus 4. This is in the form y equals mx plus b, slope-intercept form. My m, or my slope, is 2, so rise over run, this is up 2 over 1. My b value, remember I'm looking at the sign in front of that number, is negative 4. On my graph, I'm going to start at my b value of negative 4, my y-intercept, and then I'm using my slope to go up 2 over 1. I can go back the other direction, and I draw a line to connect my points. X-intercept, I'm looking for where does this graph cross the x-axis. This crosses the x-axis at the point 2, 0. Remember, my 0 is the same as the x-intercept, so my 0 is also the point 2, 0. This is the end of notes 5, 6.